Alright, I hadn't posted much on the robot here lately because I hadn't done a whole lot more work on the chassis or any of the physical parts of it here. Pretty much still where it was a few weeks ago. What I have been working on is some sensor circuits for it. One of them was the I don't know what else to call it, but kind of like an IR consolidator, because I'm going to have quite a few of these little IR proximity sensors that go around the sides of it. And instead of having 8 of my I/O lines tied up monitoring each of these sensors separately, what I wanted to do was create a separate little controller that would run all those sensors, and then I could report on what the state of those sensors were by talking to that control board. So I took a little excursion to the land of the PICAXE controller, and this is what I came up with over here. This is a PICAXE 20X2. Reason I happened to pick a 20X2 was that it is capable of doing or acting as a I2C slave, which is the 2 wires that are running here from this main controller over to my test circuit here. So it's able to communicate digitally with just these 2 wires. So just to test the setup, I had 6 digital sensors, 6 of those digital IR sensors hooked up over here. They all come to this little PICAXE controller. It's running a program that monitors all of these sensors, and then whenever it sees one of those sensors get tripped, then you can see that yellow light over there turns on to indicate that it's seen a change in the sensor states. The green light over there would be for some circuitry that I'm going to add a little bit later to actually turn all these IR sensors off. If the robot isn't moving, then I should be able to turn all of them off and save several hundred milliamps of power while it doesn't need to be watching those things if we're not moving. So anyway, some other things that I added to the circuit were the ability to I guess the best word for it would be debounce the input. So it doesn't trip if I'm waving my finger really quickly over the inputs. Even though they sensed every single one of those times my finger waved over it, it didn't trip. And the idea there is that if I have any noise or any little quick false positives that get transmitted to these things, it won't necessarily tell the robot that it's about to run into something. That's what I don't want to have happen. So it takes a little bit slower movement for it to catch it. Here I can control how sensitive it is. I can make it very insensitive to where it takes a fairly long period of time for something to be in front of it before it trips, or I can make it very sensitive where it's almost instant. So that's the basic idea. I've got, like I said, I've got 6 of these sensors set up right now. And now I'll kind of show you how the circuit works here between the main controller and this sensor board. So what I got here is a serial program running that shows me what the main controller is doing, and I've got a menu of things that I can do with that little subcontroller. So right now it's showing that none of the inputs are tripped. So what I'm going to do is I'm going to swing this little breadboard over the top, and you'll see them light up. Underneath there you'll see the little red lights come on. And it's also showing that it's detected them. So we'll come back over here. And now you can see that we've got 4 ones. These 2 ones here and these 2 ones are showing that those 4 sensors are tripped. Now if I move that away, come back, now it's showing that we've got no activity. You can see there I can set the debounce speed, so anywhere from 1 to 9, 1 being absolutely no delay. It will report them as fast as it sees them, and 9 would be almost like an 80 millisecond delay, and during that delay it checks them numerous times and they have to match every single time it checks before it will report them. Then you can see there we've got some other menu items, the number 10 being shut down. So if I go over here and if I give it that shutdown command, you've got that green LED up at the top. So see, when I tell it to shut down, that little green LED went off. And what that LED will actually later be used for is to trip a transistor that will be supplying the power to all of these sensors. So whenever that green light goes off, then those sensors would be powered down, not using my battery. Okay, so then I've got number 11. I can turn it back on. It sends the command to the controller and we're back on. Okay, now I'm going to wave my hand over the top, and even though I'm leaving my hand in place, you'll see that that yellow light isn't coming on. That's because it's still in a disabled state. It got turned back on, but it hasn't been enabled yet. So with a command here, I can go and send it an enable command. And now, when I wave my hand over, you get the yellow light again. So it's enabled, it's reporting its sensor conditions. Moving on here, the next item you see down there is the set mask. That was another idea I had that I thought would be helpful with the bot. And the idea there is that I can mask off inputs that I've already seen. So I'm going to go ahead and set it up so it's tripped those 4 sensors again. We're going to hit enter. Okay, so we see that all 4 of those sensors are tripped. Now what I'm going to do is type that 14 and tell it I want to set my mask to mask off those 4 sensors. Okay, and now what you'll see there, what it did was you've got those 4 zeros are the sensors that I don't want to pay attention to anymore. So you can see what the mask that was set in the device when we started was. Here's the mask that we want to change it to, and there is what we're reading back from the device after we finished with the command. So we now know that our mask is set. Alright, so now we'll look over here, and if I trip any of these bottom sensors, you'll notice that the light does not come on anymore. However, if I trip one of these side sensors, it still comes on. So it no longer cares about these 4 bottom sensors, it's going to ignore them. And only these 2 sensors will now cause it to activate. So the idea behind that was if I have run into something in the front, then I want to be able to say, I want to still pay attention to my IR sensors, because if I'm backing up and run into something, I want to be able to detect that, but I don't want it to continuously detect that it's bumped into something in the front. Because it kind of simplifies my code if I can tell it to ignore those front sensors till we're done, or till we've run into something else. So that mask ability means that all I have to do is tell that sensor controller that I don't want to see those anymore, and it will stop reporting them to me. So my behavior code doesn't have to take them into account anymore. I'm going to see how that works out. It was just an idea I had. I thought that might be helpful. Okay, so the next command we have down here is to clear that mask. So if I type that in, it's going to send that command. And then what that's going to do is clear that mask off so that now we're paying attention to all those sensors again. You'll see that I wave my hand over the top and it trips it. Then we have a reset command that will just completely reset the device as it was when it powered on. And here's a little command where we can show the current mask that's sitting in there, and now you see that it is indeed paying attention to all of its sensors again because they're all 1s. So that is the basic command set that I set up for it. Don't think I'm going to go too much further with it. That's all I wanted to get done. The idea behind doing this was I now get the benefit of up to 12 sensors, and I can read all 12 of those sensors through these two lines rather than taking up nearly 12 I/O on my control board here. I will probably add this particular line here that's making that yellow LED come on, because I want the I don't want the controller to have to constantly go out and check and see, is something tripped, is something tripped, is something tripped. What I would like to have it do is to get a signal from this board that, hey, something tripped, and then I can go out here real quickly and read and find out what it was. So I will end up, using another I/O line. It won't be just these two, but at any rate, it's still a significant reduction in the number of I/O lines that I need to have that same number of sensors set up. So I'm going to actually do a very similar thing with some of the rest of my sensors that I'm planning to use. All of these ping sensors here, or these ultrasonics, can be set up the same way. And all of these passive infrared sensors, they can all be set up the same way too. So I should be able to get quite a few sensors all set up and coming into my main board without using up very much I/O space at all, because they can all ride on these same two wires, because each device is separately addressable. So I can talk to any number of devices as long as they have a different numeric address using the same two lines.